we covered a DC current. In DC current, the current is constant and also voltage is constant. But in AC, that is alternating current, current and voltage both are changing with time. So this is the difference between AC and DC. So first of all, let's see resistance in AC circuit. So in this circuit, we have one resistance connected with AC sources. This is the AC source. Voltage is given by this expression. V naught is the peak voltage and B is average voltage. Average voltage is equal to V naught sine omega t. So omega is 2 pi f, right? In a circuit consisting of an AC circuit and a resistor, both the current and voltage vary simultaneously. So current and voltage both are changing simultaneously, but they are in phase. So let's see another slide. This is the voltage curve, which is changing with time, and this one is current one. This is also changing with time, but they are in phase, right? Phase means they are facing into same time. They are facing in particular direction, same direction. So if you look at this figure, what you can see is this part of voltage is positive and this part of voltage is negative, which are equal. So if you add these two parts, it is equal to 0. So average value of voltage and current over a complete cycle, it is forming a one complete cycle, is 0. So it is important to get root mean square value of current and voltage, because if we take the peak voltages or peak currents in one complete cycle, it becomes 0. Okay. So how can I calculate power? The instantaneous power can be calculated by using the instantaneous current. Instantaneous means, meaning of instantaneous is the current is a particular instant, right? So this is the expression of power from DC circuit also. It's the same. So power is equal to square of the current multiplied by resistance. And if you insert the value of I, which is I naught square sine square twice phi omega t. It can be taken from this slide, right? The current I, average current I is equal to I naught, which is peak current sine omega t. Okay, so we can get this expression. So after simplifying this one, I mean getting the value of sine square 2 pi ft. First of all, we have to get the average current. To get average current, square of the average current. So square of the average current is square of the peak current. This is the maximum current at the peak, right? Sine square omega t or twice phi f t. So this thing right here can be calculated. We know sine square theta. I'm gonna to say sine square theta instead of sine 2 pi ft. Sine square theta. You know, simple trigonometry. Sine square theta is equal to what? 1 by 2 half 1 by 2 1 minus cos theta, right? Cos theta. So if theta is 90 degree, then this cos will be 0. Okay, this will be 0. So sine square theta is equivalent to 1 by 2. Okay, so this is 1 by 2. This whole thing gives you 1 by 2. That's one. And then square of the average current is equal to half square of the peak current. Okay, so from that you can calculate the average power. Average power is equal to average current squared into R. You will get this expression. Okay, let me clear these changes and then go ahead. So this is the average power. Look at the plot of average power. Average power P bar is equal to half of P peak. Because when using power in instrument, we need the average power, right, to run that instrument. So that is the important. Average power is important. Peak power, it will not sustain for longer time. It will come and go away because this is fluctuating power. So average power is important to run devices. Okay. So what is the root mean square current? IRMS. So in a complete cycle, the total current is 0. That's why we have to calculate the root mean square current. It is a square root of square of the average current, and we know square of the average current is equal to half of the square of maximum current, or you can say peak current. This one, let me write it down. This is a peak current. Okay, P E E K, peak current. Peak current. Peak current, right? So root mean square current is equal to peak current divided by square root. And if you calculate this one, this constraint term, it will be 0.707 I naught. Okay, let's go ahead. Similarly, we can calculate root mean square voltage, which is peak voltage divided by root square 2, and you will get similar kinds of expression is like the current. And finally, we can express average power in terms of peak voltage and RMS voltage, root mean square voltage. Okay, so average power of the resistance AC circuit is equal to root mean square current into root mean square voltage, or square of the root mean square voltage divided by resistance. Okay, so when we are talking about voltage and the currents, we are talking about RMS values of voltage and the current, not peak values of voltage and the current. Because if we consider peak values, they are fluctuating, and in one complete cycle, they are going to be 0. Average will be 0. So when you are saying our household voltage is 120 volt, that means root mean square voltage, not a peak voltage. Peak voltage is around 170 or more. Sometimes it is fluctuating more than 170 also, or sometimes less. Okay.